Now, the third one is the formation of colorful ion. We are going to use two theory, valence band theory and crystal field splitting theory. What am I going to explain in here is not extremely important. If you can understand, very good. Cannot understand, then never mind. If, let's say, STPL question really come out this kind of question, then you try to avoid. But if you know how to answer, then that will be very good. Okay. Okay. So usually when you learn to a higher levels, higher and higher level, we sometimes, if you use only a one single theory, you cannot explain very well on how does something happen. You have to use a mixture of theory. So this is one of them that we are going to use the what we call as the valence band theory and crystal field theory to explain the formation of coordination compound and how does the color form and its magnetism property. Okay, so it is a combination that is used to explain three things together in one shot. Okay, so with that explanation, let's have a look at what is the valence band theory here. Now, actually, valence band theory, we already learned in our semester 1. Hybridization, sp3, sp2, sp is a type of the valence band theory. But if you can still remember, in our valence band theory, for example, last time when we learn, for example, last time if we learn this one, if we learn the how to draw CH4 okay, so CH4 we have ground state current. So in ground state you have 2s2 2p2 isn't it? Remember? Then we have excited state. So in excited state you have 2s and 2p, they put in the same energy level where one of the electron from the 2s excite to the 2p remember? Then we have a hybridized state. Hybridized state because you want to explain CH4 so it's you form sp3 where all of them have this one. So because it's sp3, the shape of the carbon is a tetrahedral. Remember that? Then, okay, in here, you have one electron inside there. So let's say hydrogen, because you want to draw hydrogen, so you must prepare an orbital hydrogen because it's 1s, isn't it? So if 1s1, so you have a sphere 1s with one single electron, hydrogen. So hydrogen come and overlap, okay, to form covalent bond. Hydrogen come and overlap, form covalent bond. Hydrogen come and overlap, form covalent bond. Hydrogen come and overlap, form covalent bond. Okay, so this is how we initially learn the valence band theory, isn't it? Okay, so that is how we learned previously. But in this case, in the formation of complex, you will see that in the complex form, let's say Zn, later you see, the orbital form here is empty, no electron. Okay, the hybridization is here is empty. So that what happened next is, if you want to attach ligand, let's say NH3 because NH3 carries a lone pair electron that is readily to form dative bond. So the NH3 come and overlap in here. So because one orbital can only occupied by 2 electrons, isn't it? So when you try to overlap, so the lone pair electron from the ammonia will form the dative bond to the zinc and overlap with the empty orbitals inside the zinc. So that is more or less the concept of this valence band theory inside the formation of the complex. Okay. Okay. So I'm about to explain this theory already. Okay. So so valence bond theory, which help explain the bonding and the structure of the main group compound. Okay. Is also used to describe the bonding in the complex ion. So the formation in a complex ion, the few ligand orbital overlap with the empty metal ion orbital. So the ligand which act as a Lewis base donates the electron pair, and the metal ion which act as a Lewis acid accept it to form one covalent bond of the complex. Okay. So since valence bond theory can be related to the hybridization, therefore once the shape of the complex is known, the hybridization occur in the center metal ion can also be deduced. So table below summarize the coordination number, the shape complex as the hybridization. So if your coordination number is 2, then your shape must be linear, isn't it? So the linear, the type of hybridization is here is SV. Okay, so if coordination number equals to 4, then it can be tetrahedral, it can be square planar. In tetrahedral, the hybridization is sp3. In square planar, the hybridization here is dsp2. Then for coordination number equals to 6, the shape of the complex is octahedral. So octahedral, you have two possible type of hybridization. Either it is D2sp3 or sp3d2. So how different are they? Later I will explain together. Okay. Okay, so let's without any hesitation start to explain all the shapes in here. Okay. Okay, so okay, so now never mind. We shall continue in our next lesson. Sorry, because I got something on. So later we continue on. Okay, I'll stop at here. Okay, for today. Sorry for today. Sorry, I got to end my lesson for today. So I'll see you all on next lesson. Sorry.